I'm Andy George. I'm a Co-Young America applications engineer. I work in Atlanta, and we want to introduce the Neptune C Plus for you today. So a little about the Neptune is we test conformal coating. So we're looking at the coatings on the board. We can see you can see that it really lights up under UV light, so we can see where the coating is, where the coating isn't. So as we're making our inspections, we really have two processes. One is the 2D, where we're looking where the coating is, where the splash is, and then we're looking where the coating is not. So we want to find splashes, and where the coating is, bubbles. So if we look at the bubbles, you can see where it's finding the bubbles on the screen, finds everything here, and where the conformal coating is on the board. So that's a kind of a classic 2D function. And then we also just have the non-coating. So we're looking for where the coating is not, making sure there's nothing there, and we find splashes and spillage and overspray for that. And then when we get into it, we want to make sure that as you conformal coat the board, everything is really consistent and the same thickness across the board. So that's when it's really valuable to do the thickness measurement across the board. So as we go through, we can measure the thickness of where that is as a sample going across the entirety of the board, making sure it's consistent, same thickness within your spec, and all good. You can see it creates a 3D image as it scans across that point. We can make sure that the values are correct, and we can do a scan, and we can see where the copper layer is and where the top of the conformal coating is, and that's where we make our measurement using lift technology. So a little bit about a lift. Lift is what we use to measure the thickness. Laser interferometry for fluid tomography. It's a big word of saying that we shine a laser down and it bounces back, and we can measure the phase shift as it goes through the thickness of the conformal coating. And we get very accurate measurement across the board. Along with that, we have IC thicknesses. So as we look for the IC, we can take two different measurements on the lead of the IC. We can measure on top of the shoulder to measure the thickness on there to make sure the coating didn't slump off of it, that you still have the amount of coating you need on top of the shoulder, as well at the end of the lead tip. Again, you can do the scan image and see where that lead tip is, and see where the conformal coating is, and get an accurate measurement that you have the coating where you need it to be. And we actually look at the gap, so we look at the area in between the leads. So if we're looking in between the leads, you don't have too much conformal coating pulling up over the top of it, where you don't want it, or that you have enough where you need it. And again, you can see the measurements on each one where that conformal coating is, and again, you can scan to see exactly this conformal coating in between the leads. So you can see there's less conformal coating here than on the other side. And that's it in a nutshell.